The experiment to measure the standard meter in terms of the wavelength of the cadmium red light was first performed by Michelson and Benoit in 1895. It is not possible to count the number of fringes which cross the field of view if mirror moved through whole length of 1 meter. Even not possible to obtain fringe for path difference greater than 20 cm. Therefore, the mirror must not be moved through a distance of more than 10 cm. In practice 9 etalons were used, each being twice the length of the preceding etalon. The length of the shortest etalon used is 0.390625 mm and of the longest was 10 cm. Etalon is substandard for length that consist of 2 plain parallel mirrors silvered on front faces with distance between them L. Light from source S after passing through the lens L is incident on the glass plate A1 portion of the beam is reflected towards M, and other part after reflection from M falls on the mirrors M1, M2 of the shortest etalon and the fixed mirror M1. The center of M lies in a horizontal plane parallel and above the plane containing the centers of M1 and M2. P is the reference plane and is the image of M1. Mirrors M1 and M2 re-adjusted such that their planes are parallel to the reference plane P. We can observe circular fringes in field of view of both the mirrors M1 and M2 when seen through the telescope T having a small aperture. Then the mirror M1 is adjusted so that reference plane P makes a small angle with M1 and M2. When the reference plane P intersects the plane of M1 in middle, it forms shape like air wedge. We can see straight line fringe. Now instead of white light use cadmium light. Fixed mirror M2 is adjusted as parallel to M1, so that we get circular fringe. When M1 is at position E, in M1 we see straight line fringes. When we use cadmium light, we see circular fringe in mirror M2 at infinity. The mirror M1 is moved and the number of circular fringes that cross the field of view. When the plane of reference P intersects the middle of M2, straight line fringes will be seen in M1 white light. Throughout the experiment, white light is used to note position of reference plane P interesting M1 and M2. Cadmium light to count number of fringes. Mirror M1 moves E to F, that is thought length L of etalon, N fringe moves field of view. Then L equals N lambda by 2. To compare shortest etalon to next etalon, both of them are arranged next to each other. M1 and M3 lower mirrors of 2 etalon and M2 and M4 upper mirror of 2 etalons. First, mirror M1 is adjusted so that plane P intersect with midpoint of M1 and M2. White light used straight line fringes are observed in mirror M1 and M3. Mirror M1 moved till we see straight line fringes in M2. Keep mirror M1 fixed. First etalon moved till P coincide with mirror M1 of first etalon. Therefore, etalon has moved distance L of first etalon. If length of second etalon twice first one, then M3 and M4 will be coplanar. Then we will be able to see straight line fringe in both M2 and N4 simultaneously. Thus second etalon compared to first one. The 10 cm etalon taken as substandard and compared to prototype meter. Also used to calibrate the standard meter. These are some advantages of using a Michelson interferometer. A Michelson interferometer can measure displacements as small as a fraction of a nanometer, making it a highly precise instrument for measuring physical quantities. We can measure various physical parameters, including distance, refractive index, and wavelength of light. It is also used in Fourier transform spectroscopy, the non-destructive method of measurement, making it ideal for studying biological samples. Interferometer is based on the interference of light waves, which makes it a highly accurate and reliable method of measurement. The setup is easy to use, and does not require specialized knowledge or skills to operate. The Michelson interferometer is relatively inexpensive compared to other precision measurement instruments, making it accessible to a wide range of users and application in various fields including physics, engineering, astronomy, and biology. Even though there are many advantages, there are certain limitations too. Disadvantages of Michelson interferometer are that they are susceptible to vibrations, limited range. Alignment issues may arise. There is limitation in resolution and limited application. In this session, we dealt with Michelson's interferometer, construction, working and its application, merits and demerits. The Michelson interferometer is a highly precise instrument and can be used to measure displacements as small as a fraction of a nanometer. So, widely used in research and industry for its versatility, accuracy, and reliability. Thank you everyone.